One of the biggest advantages of the NIR Western blot over Chemi is the ability to observe two different target proteins with the same molecular weight in one image acquisition. This is referred to as multiplexing. In this case, the term multiplexing refers to using two different NIR channels to observe two or more different proteins. When multiplexing, you can look at two targets that have the same molecular weight or several targets with different molecular weights. If the two targets are the same molecular weight, as in Pan-phospho targets, ensure that the two primary antibodies are raised in different hosts. For example, you can probe your Pan target with an anti-mouse primary antibody and then a goat anti-mouse secondary antibody. For your phospho target, you could probe with an anti-rabbit primary antibody and a goat anti-rabbit secondary antibody. The fluorescently labeled secondary antibody will simultaneously detect and discriminate the two signals. Multiplexing is not limited to only two targets. You can probe for more than two targets as long as you can validate the primary antibody for proteins of distinct molecular weight. Multiplexing is a great feature of the NIR Western blot, but be aware that some secondary antibodies can cross-react with each other. To prevent this cross-reactivity, secondary antibodies can be further purified via cross-adsorption. As you can see, when the secondary antibodies are not cross-adsorbed, the band of interest in the 800 nanometer channel can also be seen in the 700 nanometer channel. The 700 nanometer secondary antibody is binding to the primary antibody, even though it should be detected only by the secondary antibody labeled with the 800 nanometer dye. This cross-reactivity is yielding the band in the 700 nanometer channel. In contrast, when the secondary antibodies are cross-adsorbed, there's no cross-reactivity in the different channels. Also, when you're choosing secondary antibodies, if possible, make sure that the secondary antibodies are derived from the same host species. For example, you'd want to use a goat anti-mouse and a goat anti-rabbit secondary antibody to eliminate the chance of the secondary antibodies interacting with each other. If you use two secondary antibodies that are derived from different host species, such as donkey anti-mouse and goat anti-rabbit, they could potentially interact with each other. The secondary antibodies are interacting with each other, and that's leading to the band that's present in both channels. So now that we've discussed the important considerations when choosing your secondary antibodies, we will next discuss how to prepare your secondary antibody solution.